domain of all that stuff. And I'll write it on there where y'all can see it a little bit better. F of x is equal to x squared, and g of x is equal to square root of 36 minus x under the radical. They want, well, let's just write f of x is equal to x squared, and g of x is equal to square root of 36 minus x. Now, I don't care what the directions say. They're going to want these three things. So let's go ahead and do those. So f composed of g. That means that we're going to rewrite f in terms of what? Big A, big parentheses, sorry. Fixing to say something I shouldn't have said. Big parentheses. And then what are we going to plug into the parentheses of f? G. Square root of 36 minus x. All right, that's one. G composed of f. G composed of f of x is equal to 36 minus parentheses. And what are we going to plug into those parentheses? X squared. In fact, let me go back and do something. You don't have to do anything. I'm doing it for you. You can take your, I'll tell you what you can do though. If you got any highlighters, get them out. Because this might help you in your homework to highlight. Yeah, just come on in whenever, that's fine. Square root of 36 minus x. And here, you might want to highlight those two guys. There. So that way you'll know, well, finally, you decided to be with us. Appreciate it.
No problem.
And then f composed of f. So what are we going to do with f? We're going to rewrite f with big what? Parentheses. And what are we going to plug in for right here?
X squared.
X squared. We're going to plug itself in. There we go. Now there's the three things that they want. Now all you need to do is simplify them. So let's simplify them. What happens when you take something with a radical and square it? What happens? Well, the index and the square cancel. So this guy cancels. So f composed of g of x is equal to what? 36 minus x. And what's the domain of that function? What I tell you, if it didn't have a radical or a fraction, what is the domain? All real numbers. So you can plug any number you want to in there. Plug in a 0.5, plug in a negative 0.6, plug in a negative 1/2, plug in a positive 1/4, plug in a positive 100. You can plug in anything you want to there. Because it's x to the first, x to the second, x to the third, x to the fourth, and so on. Any of those, all real numbers. Unless specified by the instructor or the instructions. And in this case, they do not specify, they just say what is the domain. This, there's nothing you can do to this. The only thing you can do is change it into the square root of x plus 6 and x minus 6. But can you take the square root of anything? No, you cannot. Now what's the bait here? Yeah, they try to get you to say, oh, well, that's x minus 6. And a lot of students fall for it. Now, we're going to find the domain of that in just a second. What about this one? Say again? X to the 4th. Using what rule? Power rule. Good. I want y'all to know that so you won't sound ignorant when you do go up in math and somebody asks you what you do. Oh, well, you take them two exponents and you multiply them together. No, you say power rule. Okay, what's the domain of that function? All real numbers. So here and here is all real numbers. But that middle guy, you know it's not all real numbers. Why? Because it's a radical. And it has an even index. And an even index, you can't have what? You can't have a negative in radical, Hubert. That's right, class. So, we're going to take this to the next page, or make a whiteboard. And we're going to call it G composed of F. Is that what it was? Equals the square root of x squared minus 36. Or the square root of x plus 6 times x minus 6. Now the reason I'm doing this is to show you that you can't do this. You can't do that. You can't take the square of x squared and the square of minus 36 because they're together. So you can either do this or you can do this. Either way, you've got to set the radicand equal to what? You got to set it equal to 0, Hubert. That's right, class. Why you got to set it equal to 0? Because that's the difference between positive and negative. And what are you checking to find? What gives you a negative in the radical? Because you don't need that. So, bring that 36 over, and you get x squared is equal to 36. X is equal to positive or negative what? So, negative 6 will give you a 0, and positive 6 will give you a 0. So now we've got to check to see what's going to give you what. So here's negative 6. Here's 0, and here's positive 6. We know that negative 6 will give us what? A 0. And positive 6 will give us a 0. Can we take the square root of 0 in the calculator? Yes, square root of 0 is what? 0. So we can have the square root of 0. We just can't have the square root of negative. 0. Let's plug 0 in. 0 minus 36 is what? So can we have negative? Can we use 0, anything between negative 6 and 6 in our function? 3. 3 squared is 9. 9 minus 36. No. So we're going to take a handy dandy red highlighter and we're going to highlight this because that means we can't what? Use those numbers. Now let's check and see negative 7. Negative 7, what happens when we do negative 7 in the... What happens? We end up with a negative or a positive? So can we use those numbers? Yes. And we know this arrowhead is called negative infinity. And what about these guys? 7. What happens when we put 7 in there? We get a what? So we can use this guy, and this guy is called positive infinity. So let's write our domain in terms of interval notation, because that way we read from left to right, and that's what y'all been doing ever since you were a kid. So let's read left to right. Well, it always goes on infinity. Parentheses. So negative infinity to what?
-6.
Can we touch 6?
Yes.
Yes, because you can take the square root of 0. And this is not an intersection because nothing overlaps, so it's a union, which I don't care about that. But and then what?
6.
2. Good job. And that's your answer. That homework question is a good test question. So you might want to highlight that one. Now, who's got a question? When in doubt, graph it. When in doubt, put it on the number line. Hopefully you feel good about yourself. Let's do another one, because I want you to feel confident. Let's see if this thing will make a good one, or is it just going to make a... All right, you try that one. I want you to do all 3, and then I want you to do the domain for all 3. Let me blow it up for you. It's about the same. It's just x squared and 16 minus x.
You blow it up a little.
I'm trying. Give me time. There, how's that? Is that better? F composed of G. So I'm going to rewrite F with a big set of parentheses and then plug in the square root of 16 minus x. And of course that's going to give me 16 minus x, which the domain is all real numbers. I'm going to go ahead and do the last one. The last one is f of f. And that means I'm going to rewrite with a big set of parentheses and plug in x squared, which again gives us x to the fourth, which is all reals. Now the last one, g composed of f, is going to be, I'm going to rewrite g, and I'm going to put a big set of parentheses in it. Oops. 16 minus a big set of parentheses, and I'm going to plug in x squared. And that becomes the square root of 16 minus x squared. So take the Bradicand out. The x squared is equal to positive or negative what?
4.
So your domain here is going to follow the same pattern as the other one. It's going to be from negative infinity to what? Negative 4. And then from 4 to what? Positive infinity.
I don't understand. Because if you did like negative 5 and you plugged it into that, it would be 16 minus 25.
Okay, we might have to do it. It's different. What was the one up here before? The previous problem.
Well, on the other one,
36 minus.
What was it?
36.
Okay, well let's go ahead and put it in on the.
But I think in the other one, you
Mhm.
switched them around so that it was x squared minus 36.
Did I?
And they didn't.
Okay, well then I shouldn't have done that. Then I'm sorry. Okay, well let's fix both of them then.
'Cause the
Let's
answer-
fix this one. You're right. You're
The
right.
answer that was shown on the other one wasn't the answer that.
Hold on. Let's. I might have turned it around. I'm sorry if I did. So that would be positive. Let's go with negative 4, 0, positive 4. And let's plug in negative 5. Negative 5 will give us 25. Okay, so yep, you're right. So then we'll take our handy dandy red, and that'd be, can't use those numbers. 0, 16 minus 0 would work, so green would be in the middle. And then 5 would give you the same thing, right? Yeah. So I was wrong by turning them around. I didn't know I did that. I'm sorry. So on both of these, the domain on this one would be from negative 4 to what?
4.
Positive 4. And on the previous problem, it would be the opposite. I'm going to fix that for you on the next slide, because I don't want anybody to be confused. So there we go. I turned it around, and I'm sorry. I didn't know I turned it around. So let me fix it. Was it 36 minus x squared?
Yes.
And that would be, I'll just use this one. That would be 36 minus x squared is equal to 0. X squared is equal to 36. X is equal to positive or negative 6. And then you negative 6, 0, positive 6. And 0 would give you, so it'd be the same. So take your green marker or red marker, and that would be that. And the other side. And then the green would be in the middle. So the corrected domain for the first one would be negative 6 to positive 6. So forgive me for switching them. I didn't know I did that. You should have said something at the beginning. It's your fault. It's not my fault.
I didn't realize it until after.
It's still your fault. I made that mistake because of you. Okay? Hopefully that'll help you out. Hope I didn't confuse you too bad. You have to watch me on things like that. Sometimes I do switch things around. I'm much better now. All right. So let's go back to our handy dandy email. Let's go down and see if we can find another one. (2.681/7). 2.681/7. You will see this one again. Not just on the test, you will see it in calculus. It's called the difference quotient. So, what do you do when you're dealing with something like this? Well, this is the same as f of 3 minus f of 2, except you've got f of x plus h minus f of x. What do you do if that was a f of 3 and f of 2? What would you do with the 3 and the 2? What would you do with it? Say again? You plug them in. So what do you do with the x plus h and the x? Plug them in. So first of all, you rewrite this in terms of what you're going to do. So that means that wherever there's an f, you've got to plug in this with wherever there's an x, you've got to put a big set of what? Parentheses. So the first part, we'll draw a little oval around this. And this is going to be this part. So negative 2 parentheses squared plus 5 parentheses plus 3. Minus, and I'll put a rectangle around this. Negative 2 parentheses squared plus 5 parentheses plus 3. And all that's over what? H. Okay, now what are we going to plug into the first do-jigger? What are we going to plug into this one?
F of x plus h.
No, not f of x plus h, but x plus h. Come on, people. If I gave you f of 3 is equal to blank, and I said f of x is equal to 2x, what would you do with that 3? You plug it in and get what? 6. So now I'm just giving you, instead of f of 3, I'm giving you f of what? So what am I going to plug in? Okay, don't go dumb on me now. Whatever's in those parentheses, you plug in. Period. F of x, f of 2, f of square, f of star plus square, f of x plus h. Whatever is in those parentheses, you plug in. Now what are you going to plug into this one? X. All right, now simplify it. And if you can't do it, you can just consider yourself what? Huh? A failure. Right? Huh? Yep. Y'all are learning. I just love this new program. It just does everything backwards from the one that we learned on. I'll forget it. So, this one is going to be a mess because you got A plus B quantity what? Shortcut number 1, Hubert. That's right, class. And if you still refuse to learn the shortcuts, then you might as well go ahead and get a degree in public relations or something, because you're going to see them until Calculus 3 and DiffyQ. So you might as well learn them. So -2, I just say that in general, because there are some students that refuse to learn the shortcuts. X squared plus 2xh plus h squared plus 5x plus 5h. Sorry about that, running into that, but yours is much better. Minus -2x squared plus 5x plus 3 all over h. Everybody with me? Now you're going to spend a whole section in calculus, first week or two of calculus doing this. So you might want to keep these, anything with difference quotient on it, you might want to keep it tabbed in your notebook for calculus. Just telling you. All right, so negative 2x squared minus 4xh minus 2h squared plus 5x plus 5h plus 3 minus be a positive 2x squared minus 5x minus 3. All that over h. Now, what's going to happen is all of your x's are pretty much going to cancel. Let's see. This 2x squared, does anything match 2x squared? Well, that negative 2x squared is canceled by that positive 2x squared. And 5x is canceled out by what? Negative 5x. So all that's left is your h terms and your constant terms. So let's rewrite it. Negative 4xh minus 2h squared plus 5h plus, oh, the 3's cancel too. I didn't know that. That's good. Don't have to worry about them either. Over h. And what can we factor out of the top? An h. And that's going to give us h times negative 4x minus 2h plus 5 over h. And what happens to the h's? They cancel. And the answer to this problem is negative 4x minus 2h plus 5. Negative 4x minus 2h plus 5. Now, I'm going to give you a little bit of peek into Calculus 1. Because I just want to tell you why this is so important. Remember this. Write that down. Negative 4x minus 2h plus 5. And remember this. Well, I tell you what, I'll just clear it.